Welcome to homework.
Okay, what is a good definition of a covalent bond? We've got electrons simultaneously attracted by more than one nucleus. So I don't know, that looks something like, uh, right, a carbon-hydrogen bond, maybe. There's two electrons, there's two nuclei. Those electrons are being attracted to both. That seems like a pretty reasonable definition of a covalent bond. But let's continue, just in case there's a better answer. Two is the overlapping of two electron-filled orbitals having different energies. I think I have a problem with that definition, and that is that consider H2, right? And we know that H2 is a covalent bond. It's not ionic, it's not H plus and H minus, right? Um, that's it's not a covalent attraction. And the energy of the uh, orbitals, right, is the same for H2. If we bring hydrogen with its 1s orbital together with another hydrogen with its 1s orbital, and I don't know if you're familiar with molecular orbital diagrams, but essentially we can diagram this out and say that the overlapping orbital will have a bonding and an anti-bonding form, and then we could put the electrons into the bond. One hydrogen brings one electron, the other hydrogen brings another. We put them both in this lower energy bonding orbital. Well, the energies, right? This is an energy scale. The energies are the same level, and these are perfectly covalent bonds. So there's nothing about a covalent bond that requires the orbitals have different energies. Okay. Three is the overlapping of unoccupied orbitals of two or more atoms. Okay, well that's the same picture. We can just point over here, right? This would be overlapping unoccupied orbitals, or uh, you know, there's no electrons in it for one. So orbitals without electrons in them are not bonds. They could never be bonds. You need electrons in orbitals that are overlapping to create a bond. So if you ask me, the idea of unoccupied orbitals being a covalent bond, I would just say no, it's just not a bond at all. And then finally, a positive ion attracting negative ions. That sounds like ionic bonding to me, and not covalent bonding. That's like the opposite. So that would be like sodium plus and chlorine plus attracting each other. Totally non covalent. And then finally, we've got an interaction between outer electrons. It's not the worst definition, and typically all bonding involves valence electrons to some extent, but it's very vague compared to definition one. That's not a very good definition, right? Interaction between outer electrons. The interaction between outer electrons can be repulsive, right? If we had like chlorine minus, its outer electrons would repel another chlorine minus. That's not a covalent bond, and that is an interaction between outer shell electrons. So one is definitely the best definition. Uh, it's electrons being shared by multiple nuclei, two or more nuclei.